Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the parent chain. The longest carbon chain containing the principal characteristic group, carboxylic acid, COH, and the double bond is counted. Starting from the carboxylic acid carbon, C1, Cu, C2, H2, C3, H is equal to C4, H, C5, quaternary, C6, H2O. This gives a 6-carbon chain, hexanoic acid. Moving on to the next step. Locate the double bond. The double bond is between C3 and C4, counting from the Co2H end as C1, giving hex 3N1OIC acid. Wait, let me recount. C1 is the carboxyl carbon, C2 is CH2, C3 is equal to CH, C4 is equal to CH, C5 is the quaternary carbon, C6 is CH2O. The double bond is between C3 and C4, so the parent name is hex 3Enoic acid. Moving on to the next step. Identify substituents on the parent chain. At C5, a cyclohexyl group and a methyl group are attached. At C6, a hydroxyl group, O, is present as part of CH2O. And for the final step, apply numbering. The carboxylic acid end is C1 to give lowest locants. The double bond is at position 3, hex 3N1OIC acid, where the 1 for the acid is implied. Substituents: 5-cyclohexyl, 5-methyl, 6-hydroxy. Hexanoic acid. Unsaturation: 3N. Substituents in alphabetical order: 5-cyclohexyl, 6-hydroxy, 5-methyl. Full name: 5-cyclohexyl, 6-hydroxy, 5-methyl hex 3N1OIC acid. Verify. The structure HO CH2C, cyclohexyl, CH3, CH is equal to CH, CH2, Cu has C1 is equal to Cu, C2 is equal to CH2, C3 is equal to CH, part of double bond, C4 is equal to CH, part of double bond, C5 is equal to C, cyclohexyl, CH3, C6 is equal to CH2O. Substituents at C5, cyclohexyl and methyl. Substituent at C6, hydroxy. Double bond between C3 and C4. This matches 5-cyclohexyl, 6-hydroxy, 5-methyl hex 3N1OIC acid. Therefore, the correct answer is 5-cyclohexyl, 6-hydroxy, 5-methyl hex 3N1OIC acid. The correct answer is shown on screen.